How do you write a quadratic function in vertex form? The vertex form of a quadratic function, f of x equals ax squared plus bx plus c, looks like this. F of x equals a times the quantity x minus h squared plus k, where a is the coefficient in front of x squared, and h and k are the x and y coordinates of the vertex. So h equals minus b over 2a, and k equals f of h equals f of minus b over 2a. Let's look at an example. Say you have the function f of x equals x squared minus 4x plus 3, and you want to write f of x in vertex form. First, you need to find h, the x-coordinate of the vertex of f of x. Recall that the x-coordinate is the same as the axis of symmetry. The formula for the axis of symmetry is x equals minus b over 2a. So, since h is the same as x in this case, you have h equals minus b over 2a. Now, find a and b. Here, a equals 1 because x squared is the same as 1x squared. b equals minus 4. Inserting these two values in the formula gives you minus negative 4 over 2 times 1. This is equal to 2. So, h equals 2. Next, find k, the y-coordinate of the vertex. You get it by inserting the x-coordinate, h equals 2, into the function f of x equals x squared minus 4x plus 3. K equals f of 2 equals 2 squared plus 4 times 2 plus 3, which equals minus 1. So, k equals minus 1. The last step is to insert h equals 2 and k equals minus 1 into the vertex form f of x equals the quantity x minus h squared plus k. So the function f of x equals x squared minus 4x plus 3 equals the quantity x minus 2 squared plus minus 1. The last term can be written as just minus 1 instead. So your final answer is the quantity x minus 2 squared minus 1. So you can write any quadratic expression, ax squared plus bx plus c, in the vertex form, a times the quantity x minus h squared plus k. But how does this work? If you want to know how, then continue watching. To prove that it works, you can use a method called completing the square. It's used to rewrite quadratic expressions in vertex form. The plan is as follows. 1. Factorize a. 2. Look at the coefficient in front of the x term. 3. Take the coefficient from step 2 and halve it. Divide it by 2. 4. Take the answer from step 3 and square it. 5. Take the answer from step 4 and both add it to and subtract it from the expression. 6. Factorize the first 3 terms using one of the quadratic identities. 7. Multiply the coefficient a by the expression inside the parentheses. Let's look at using the method for the quadratic function f of x equals ax squared plus bx plus c. Start with step 1. You factor out the coefficient a, rewriting the expression in the form a times the quantity x squared plus b over a times x plus c over a. This step can be ignored in cases where a equals 1. Step 2 is to find the coefficient in front of the x term. In this case, it's b over a. Now you continue by performing steps 3 to 5. They focus on the coefficient from step 2. 3. Have the coefficient b. You divide the coefficient b over a by 2 to get b over 2a. 4. Square b over 2a. You get b over 2a squared. 5. Add and subtract b over 2a squared to or from the original expression. You now have a times the quantity x squared plus b over a times x plus b over 2a squared minus b over 2a squared plus c over a. That sure is one hairy expression. Step 5 is allowed because when you add and subtract the same thing, you don't actually change the value of the expression. To remember steps 3 to 5 of the method, you can use the following mnemonic device: have it, square it, add it, and subtract it. Let's move on to step 6. The first 3 terms can always be factorized by using one of the quadratic identities. Notice how b over a times x equals 2 times x times b over 2a. In this case, you can use the square of the sum formula. This gives you the quantity x plus b over 2a squared. Now you move on to the final step, step 7. You multiply by a to expand the outer parentheses, which gives you a times the quantity x plus b over 2a squared minus a times the quantity b over 2a squared plus a times c over a. You simplify the last 2 terms and cancel the common factors. The last 2 terms are now minus b squared over 4a plus c. Now let's complete the formula by rewriting it to include h and k. Recall that h is equal to minus b over 2a. If you multiply both sides by minus 1, you get minus h equals b over 2a, which means you can replace b over 2a from this pair of parentheses with minus h. So, the parentheses can be written as x minus h squared. But what is the connection between the final terms in the expression and k equals f of h? Let's compute k for the function f of x equals ax squared plus bx plus c. So here, k equals f of h. H equals negative b over 2a. You insert this into the function f. This gives you a times the quantity minus b over 2a squared plus b times minus b over 2a plus c. You move on to simplifying the expression step by step. You get a times b squared over 4a squared minus b squared over 2a plus c. You cancel an a in the first term, so it becomes b squared over 4a. Next, you expand the fraction in the second term by 2 in order to get a common denominator. The first 2 terms become negative b squared over 4a plus c. It turns out that the final 2 terms in the expression, minus b squared over 4a plus c, are the same as k equals f of h. So you replace them with k, like this. A times the quantity x minus h squared plus k. Congratulations! You've just shown how to find the vertex form of a quadratic function. The vertex form of a quadratic function f of x equals ax squared plus bx plus c looks like this. f of x equals a times the quantity x minus h squared plus k, where a is the coefficient in front of x squared, and h and k are the first and second coordinate of the vertex. So, h equals minus b over 2a, and k equals f of h equals f of minus b over 2a.